Welcome to Unit 5.3. Today we are continuing to solve systems of equations with our third method of elimination. All right, so in order to solve using elimination, we're going to choose one of our variables, okay, and then we want to manipulate our equations so that they have the same coefficient, but they have opposite signs, so that when we add these two equations together, we result in canceling out one of our variables so that we are left with the other and we can solve the equation, since now there won't be two different variables. Okay, and then as always, we're going to plug back in and solve so that we have an ordered pair as our final answer. Okay, so let's get to this. All right, so different from substitution. So we are now keeping both of our variables on the same side of the equation, and we want to choose the variable where we could easily manipulate the coefficients to cancel out. So if I look at the system that I currently have, I see here that it's already set up where my y's have the same coefficient but opposite signs, okay, which is the goal, because now I want to add these equations together. So x plus 3x and negative 3y plus 3y, the goal here is for that to cancel out so that you're left with only one variable in your equation. Okay, this is so that I can now solve. Okay, this is a lot less work from from substitution, so I think that a lot of people are going to like elimination much better. All right, so we have our x, and now we just need to plug back in and get y so that we can have an ordered pair. Okay, so my final answer would be 4, -1. Okay, so this is a much quicker process than substitution. Let's take a look at another. All right, so now I see that my x variables, okay, they seem to be matching up because my y's are different, a 2 and a 6. But both of these x's being positive will not cancel when I go to add them together. If I added together the way that they currently are, I would get a 2x, which is the opposite of what we want to happen. We're trying to eliminate one of the variables. Okay, so something that we can do here is multiply the entire equation, and I'm going to use a -1 because the only problem that I have is it's the wrong sign. You want to make sure that you multiply through to every part of the equation, okay? Otherwise, you are changing the value, okay? And now it's not the same system. But now, when I go to add these together, I can get my variable to cancel out. Okay, which is the goal, because now I only want one variable here so that I can solve. You can't solve if you have an x and a y in the same equation. All right, but now I have y, so I'm going to plug back in to get my ordered pair. I get x equals 6. Okay, so I have 6, 1 as my ordered pair. All right, so if the coefficients are matching up for you, but the signs are not, you can multiply the entire equation by a -1. Okay, let's see what other situations we have. Okay, so now I'm looking at both of my variables and nothing is the same Nothing has opposite signs. This is just really not working out for me. Okay, a -1 will not help me in this situation. So the next thing you want to look for is variables with multiples as their coefficients. So my x's, a 2 and a 4, those are multiples. And I could turn a 2 into a 4 by, instead of multiplying with a -1, well, what if I used a -2? So the 2 would turn it into a 4, and I'm going to kill two birds with one stone here. I'm going to put a negative with that so that it comes out to be an opposite sign as well. Okay, so let's see. When I multiply this through to the entire equation, okay, and I bring down my second one. Okay, so now when I add these together, this is working out for me where the x's have canceled. And I can now solve this. Okay, so before we finish, let's just go back and review what happened. So I saw that my x variables were multiples of each other. And that meant I could multiply one equation to get the 2 up to a 4. Okay, and while I was already in there multiplying, I used a negative as well to get the opposite sign I need for that to cancel. Okay, so I have my y. I'm going to plug back in to solve for x. So I'm just going to go back into one of the originals. It's actually a plus. Sorry. Okay, so I get x equals -4. So my final answer, -4, -5. Okay, so we've seen so far, we multiplied using a -1 to one equation. We've multiplied to one equation using a constant that is not a -1. Let's see what else we have in store. Okay, so again, none of my variable coefficients are looking good here. Nothing is matching up. And even more than that, none of my variable coefficients are multiples of each other. So now I'm going to have to multiply both equations. So previously we were only multiplying one equation. Now I'm going to have to multiply both. Okay, so really in this situation, you can choose whichever variable you want. I like to choose the variable with the smaller coefficients, so I'm going to go with x. All right, so if I have a 4 and a 3, okay, and it's working to my benefit currently that they have opposite signs, because remember we need those to cancel. What is the least common multiple for 4 and 3? It's a 12. So I'm going to multiply the top equation by 3 and the bottom by 4. Now you can always just switch the coefficients, okay? But by thinking of the least common multiple, you're not making the numbers unnecessarily big. All right, so again, make sure you multiply through to every part of the equation. That is probably the biggest cause for error when we're doing systems like this. All right, so we're going to add these together and make sure that my variable cancels. and we have y equals 5. All right, so again, when I go back in to solve for my x, I'm just going to use one of those originals before I multiplied. But anything will do. Okay, so I get x equals 10, so my final answer, that ordered pair. Okay, so far we've seen every situation. So example 1, my variables started out with same coefficient and opposite sign, so I didn't have to manipulate. My second example, I multiplied by a -1 to get them to cancel. My third example, I used a constant and I multiplied one equation. And now this fourth example, we've multiplied both equations by a constant. Okay, so now it's time for special cases. All right, so pause your video and take a look at your two equations and determine what variable you would want to cancel and what you would do to make that happen. Okay, so if you decided to multiply your bottom equation by -3, you would be correct. Carrying that through. Okay, so those are our two equations. When we add them together now, both the x's and the y's cancel. So what do I have on the left side of the equation now? I have 0. And I get -45 plus 45. That's also canceling. 0 equals 0. What kind of statement is that? It's true. Okay, which means that this is an all solutions situation. Okay, so very similar to all solutions in substitution, we just got there in a little bit of a different way. Okay, last thing for today is our word problem. All right, so Pat and Katie are selling cheesecakes for a school fundraiser. Customers can buy French silk and chocolate marble cheesecakes. Pat sold 4 French silk and 2 chocolate marble for a total of $42. Katie sold 12 French silk and 8 chocolate marble for a total of $152. Find the cost of each type of cheesecake. So remember, when we do our word problems, we always start by identifying our variables x and y. Okay, and it says find the cost for each type. So x is going to be the cost of a French silk. I'm just going to call it a French. And y is going to be the cost of a chocolate. All right, so we're going to use a table to write our equations. All right, if you don't need the table, you do not have to make it. Okay, but for anybody who is struggling to write the equations from a word problem, I do think that this helps a lot. So we label this x, y, and total. Well, I see the word total has already showed up in the problem. So there's a total of $42, and that was for Pat. And there was a total of $152 from Katie. All right, so what did Pat sell in order to make $42? He sold 4 French silk and 2 chocolate marble. Okay, and how about Katie? Katie sold 12 French silk and 8 chocolate marble. All right, so we're going to use these two equations All right, so the name of the game today is Elimination. I see that I could eliminate my y if I multiplied my top equation by -4. Okay, so adding these together, that will cancel. Okay, and I find out that the cost of a French silk is $4. And plugging back in okay, it's $13 for the cost of a chocolate cheesecake. Okay. All right, so that is everything we need to know for elimination. So there's definitely a lot more situations that could happen in elimination than in substitution. Okay, meaning that you could multiply by a -1, you could multiply one equation, you could multiply both equations. Okay, so it's just a matter of inspecting the coefficients. But I do think that elimination is the method with a little bit less work. All right, so that is everything for today. Thank you so much for watching. I will see you guys next time.